Again, welcome to Introduction to Data Mining. In these lectures, we are going to focus on data visualization. As we said in our previous lectures, this data visualization make it possible for us to understand our data, to see a pattern in our data. For example, if I have a data set with two variables, and I want to find the relationship between these two data, I can do a correlation analysis, but another option, I can just plot a scatter plot. A scatter plot can, again, give me the quick pattern. I can see the very quick, the pattern of the data set, if there's any relationship, either increasing relationship or decreasing, or if there's no relationship. So this visualization is the conversion of data into a visual or a pictorial form, a picture, a visual, or a tabular form, so that the characteristics of the data and the relationships among the data items or attributes can be analyzed or reported. Most of the time, again, when we are doing data analysis, we start with the visualization, because the visualization of the data, we can find any pattern in the data set. So visualization of data is one of the most powerful and appealing techniques for data exploration. Humans have a well-developed ability to analyze a large amount of information that is presented visually, and also can detect general patterns and trends. I think that's one of the advantages, because if I have a data set and I plot, let's say, a two variable data set, and I plot a scatter plot, I can see the patterns in the data, if it's increasing, decreasing, or there's no any relationship. So this visualization can detect the general patterns and also the trends in the data. Also, it can detect outliers. That is, a very small value will be way away from the most of the data, or a very large value will be away from most of the data. So an example here is a sea surface temperature. We can again visualize the data set. So the following shows the sea surface temperature for July 1982. Here we have tens of thousands of data points that are summarized in a single figure. So we can see horizontal, we have the longitude, and then the vertical is our latitude. And representation is very important, especially when we are visualizing our data. Here we say representation is the mapping of information to a visual format. So the data objects, their attributes or characteristics, and also the relationships among the data objects can be translated into a graphical element, such as if it's a scatter plot, we may have a data points or lines or shapes or colors. So examples are objects are often represented as points, especially in data mining. And also their attribute values can be represented as the position of the points or the characteristics of the points. Example would be the color, the size, and the shape. Now, if I have a data set with two variables, let's say advertisement expenses and the company's revenue. If I have this data set, I may try to plot a line chart or a scatter plot, and I can see the pattern in the data, whether increasing advertisement expenses can also increase the revenue that we are going to generate, or the opposite, or if it doesn't have any effect at all. And so if position is used, then the relationship of points, that is whether they form groups or a point is an outlier, this is easily perceived. We can also make arrangement In arrangement, we say this can make a large difference in how easy it is to understand the data. Is the placement of the visual element within a display. This is an example. We can see our data attributes. We have from 1 to 6, the column, the row from 1 to 9. But the next one, instead of starting from 1 to 6, we start from 6, 1, 3, 2, 5, 4. Then instead of 1 to 9, we still have 1 to 9, but it's not in sequential order, 4, 2, 6, 8, 5. So we can arrange the data either to be in an increasing order or not to be in an increasing order. So that's the whole concept of arrangement. Here we say the arrangement also can make a large difference in how easy it is to understand the data. And it is the placement of visual element within a display. So we have a data set as a tabular form, and we change the arrangement of it on the right side. Also, selection is very important. Remember, always we said when we are doing any research, we always use the sample data, because taking the population data will be a lot of data. Population size is very big. So sample is more better. If you use population, we are going to consume more time to get the data from all the population. And also it will be more expensive to even to store the data. So we always do subset selection of a data. So yeah, we said selection is the elimination or the de-emphasis of certain objects and attributes. We are selecting some part of the data set. We are not using all. So some will be eliminate and some will be keep. So selection may involve the choosing a subset of attributes. Dimensionality reduction is often used to reduce the number of dimensions to 2 or 3. And we will discuss about the concept of dimensionality reduction, which normally use the linear algebra techniques, finding the hygiene vectors. So selection may also involve choosing a subset of objects. A region of the screen can only show so many points. Can sample, but want to preserve points in a sparse areas. We can sample it, but again want to preserve points in the sparse areas. So visualization techniques, we have so many different types of graph. Here we are going to start with the most simple graph, which is the histogram. Histogram can give us horizontal will be our time period or whatever we are measuring. Then always vertical is the frequency. So I can have a data set saying that red is 20, blue is 40, and the rest. We can use this to again come up with our histogram. Getting the histogram first is good to have the frequency distribution table. So usually the histogram shows the distribution of values of a single variable. Now divide the values into bins. Bins means the intervals. So I may have a value, the ages are from 0 to 100 years. I can decide to divide the values into bins by saying, okay, from 0 to 10, 11 to 20, 21 to 30, up to 91 to 100. So when we have the data set arranged, in this case, we have 10 bins. We're going to have 10 intervals. Also, the height of each bar indicate the number of objects. So in histogram, the height is always the frequency. So for example, here we can say, okay, between 0.5, we have around 8. 1 is somewhere around 7. And the beginning is all the way to 40. So vertical is the count. In this case, we are doing the petal width. So horizontal is the petal width. Same thing, we can plot how many flowers the petal length is. So here the petal width tells us how many flowers with different width. So when the width is 1, we have around 7. When the width is 2, we have somewhere around 22 flowers with the width 2. So also we can do the two-dimensional histogram. In two-dimensional histogram, we can see we previously use only the length or only the width. Here, two dimension means we have two attributes, independent variables. So we have the petal length and petal width with the count. So this will show the joint distribution of the values of two attributes. Example will be the petal width and petal length. And here they say, what does this tell us? Just by looking at the graph, we can see that we know the class of this data set is 3 different attributes. So here we can see all the classes are equal, the quantity of each item in each class is the 3 classes, vesicular and other 2 names, Virginica, vesicular, and one more. So another visualization technique is using the box plot. Box plot was invented by John Tukey about the exploration of the data. Now with the box plot, we need at least a minimum of 5 values to be able to plot it. One will be the mean, media. Then we have outliers. We have the maximum value, which will be the 10 percentile. Then we have the minimum value also. So this should give us 100. Between maximum and minimum, we should have 100%, unless we have outline. So 75 percentile will be the Q3, 50th percentile will be the Q2, which is the median, and then 25 percentile will be Q1. So we can use the box plot basically to understand the values of our data set. So this example of box plot, we can see that the first one here have the highest mean. The mean is almost 6. Now the rest we can see they are down. Yeah. Scatter plot also is used for double variable. If I have a data set with double attributes or 2 attributes, we can do scatter plot. Here we want to find the relationship or the pattern among the 2 data sets. So here we say attribute values again determine the position. 2-dimensional scatter plot, most common, but can have a 3-dimensional scatter plot. Here we say often additional attributes can be displayed by using the size, shape, and color of the markers that represent the object. And also it's very useful to have arrays of scatter plots, can compactly summarize the relationship of several pairs of attributes. And we see example in the next slide. So here we have scatter plot for array of arrays attributes. Each box represents X and Y. And we can see that in box 4th row, 3rd column, the intersection, there's nothing in the box. So we also have the contour plots. Contour plots is very useful when continuous attribute is measured on a spatial grid. Also, they partition the plane into regions of similar faces and values, and also the contour lines that form the boundaries of these regions will also connect points with equal values. Now, the most common example is the contour maps of elevation. This can also display temperature, rainfall, air pressure, etc. So this is an example of a contour plot example. And we can see Africa is somewhere here. Then we have America and Pacific. We can also use the matrix plots. You can plot a matrix plot, and then this can be very useful when objects are sorted according to the class. And we say typically the attributes are normalized to prevent one attribute from dominating the plot. Then plots of similar and or distance matrices can also be useful for visualizing the relationship between objects. So examples of a matrix plot are presented in the next two slides. So this is an example. We have the Sapir length, Sapir width, Patel length, then Patel width. In our counting section, we have Virginica, Versicolor, and Setosa. And this is another example again for the classes section. The previous example is for the Sapir length, width, and Patel length and width. Now we are dealing with the classes of the. So here we have the Setosa, Versicolor, and Virginica. This will be the three classes that we are going to predict. And also we can use the para coordinates. This can be used to plot attribute values of high dimensional data. So this means instead of using perpendicular axes, we use a set of para axes. Again, the attribute values of each object are plotted as a point on each corresponding coordinate axis. And the points again connected by a line. So we say each object is represented as a line. Often lines represent a distinct class of objects grouped together, at least for some attributes. And also ordering of attributes is important in seeing such grouping. So this is an example of parallel coordinate plot for arrays. We also have the star plots, which is very similar approach to parallel coordinates, but the axis is radiate from a central point. Now the line connecting the values of an object is called a polygon. And also the Chernoff faces represent an approach created by Hermann Chernoff. This approach associates each attribute with the characteristics of a face, and the values of each attribute determine the appearance of the corresponding facial characteristics. So this is an example for Setosa 1, 2, 3, 4, 5, Versicolor, and Virginica. And this is the classes for Setosa, Versicolor, and Virginica. So that will be the conclusion of our lectures on Introduction to Data Mining. So again, I wish everybody the best. If you have any question, again, send an email. So here again, we study the visualization techniques and also the general concept, what we can do and what we cannot do. So again, wish everybody the best.